Hello and welcome to another episode of the Shephard Defence Podcast. I'm your host, Ben Vogel, joined by our team of journalists to look into the big issues in the field of defence. So it's hello to naval reporter Harry Lye.
Good afternoon, Ben.
Air editor Tim Martin.
Hi, Ben.
And training and simulation reporter Norbert Neumann.
Hi, Ben.
So welcome to everyone. In this particular episode, we'll be taking a close look at maritime UAV programmes, those in development and the various problems and opportunities that unmanned aircraft present in the maritime domain. So, Harry, as our naval expert on the panel, I'd like to start with you, if I can, and just ask you about the state of play in the UK. Is the Royal Navy moving at speed properly to harness the full potential of drones?
I don't know necessarily about at speed. I mean, they are going pretty quick, but a lot of their they've got long-term ambitions to integrate drones, UAVs, UXVs, whatever you want to call them, into the fleet as part of their future maritime aviation force. So that's kind of covering everything from some kind of fixed-wing drone that could act as a companion to the F-35, all the way down to small UAS for carrying Bergen backpacks ashore for Royal Marines, to heavier lift capabilities, things for finding submarines. So yeah, I think it's safe to say there's quite a lot of work going on, but there's also a lot of long-term ambition in there.
So how is the Navy actually marrying long-term ambition with short-term priorities? Because presumably there's a lot of operational feedback from recent deployments that's going to inform the development of UAVs for the Royal Navy.
Yes, I think a key part of it is there's a lot of experimentation going on. You've got Project Vixen, Project Vampire, Proteus, the heavy lift UAS framework. So all lots of different pockets of experimentation going on across the Navy with the same goal of getting these UAS, UAVs, whatever you want to call them, into service.
You mentioned the heavy lift cargo and logistics transport side of things. So, the UK has a new framework in place, I believe, that was only very recently released, that I believe Tim wrote about. Perhaps, Harry, you can give your perspective on that, and then Tim can chip in.
Yeah, it's definitely worth getting Tim's thoughts, and I was going to ask him for those myself as well, as he wrote an excellent story which you can find on Shephard News about it. But it's definitely an interesting step in the right direction, and it seems to be building on some of the work the Royal Navy's already done with things like the Malloy UAS in terms of ship-to-shore transfer of equipment. I mean, currently you have to do that with helicopters, which are expensive, and it means that they can't do other missions that are probably more important. So there's definitely a big drive to get these kind of cargo UAVs into service, because you can see where it would alleviate pressure on the kind of the crewed helicopter fleets that are expensive, take a lot of maintenance and a lot of training.
What are your thoughts on that, Tim?
Yeah, maybe a bit worth mentioning a little bit of background to this. So the framework or analysis prior to launch of kind of a contract notice in early August was that the Royal Navy had kind of set out an RFI previously in early 2021, and with that as kind of the main foundation of this, subsequently they've added a little more detail then in terms of how it's broken down or what the kind of requirements are. So they in terms of kind of the key areas, they're looking for, to begin with, inter-theatre lift and intra-theatre lift. So that's ship-to-shore and ship-to-ship solutions, really. And kind of they've mentioned that in the next stage, competitions might potentially drop to lift requirements down to 50 kilograms. So really what they're suggesting is that they really want to accelerate market developments. So they're looking for one or more partners to kind of assess BV loss, payload delivery, and then they'll kind of also look at what they've said are not novel technologies. So you're talking counter UAS technology, software, and fuels, and so forth. And yeah, I think it's interesting because you have companies like BAE who have the T650 UAS, which kind of give you some sense of the capabilities. You're talking about a 300 kilogram payload, range of 30 kilometers, and speed of 140 kilometers per hour. So in terms of kind of the mechanics, then you just have to, I guess, hold tight to see when decisions are made from the Navy. But I mean, this isn't going to lead to a procurement, as Harry was kind of previewing. It's just experimentation and so forth. But yeah, absolutely worthwhile endeavour, and yeah, we'll see what comes of it. Certainly in the next 6 months or so, and beyond.
Yeah, it gives an interesting indication as to the future direction of travel, certainly. Thank you, Tim. And in terms of this new framework that Tim's been talking about, Harry, is there any connection between that and the Navy pods concept?
There's not kind of immediately, but you can see where the Navy is going with all of these different threads. I think Tim made a good point about the importance of kind of at this stage being intra-theatre and inter-theatre lift. I mean, when you've got a littoral response group or some kind of task group made up of lots of different naval ships, all with different needs, and you've got a stored ship in there and maybe an oiler as well, I don't think people fully kind of maybe they underestimate the amount of movement between those ships that happens, and the amount of ease of use and reduction in cost that using UAS to just get bits around the fleet would bring. And so that's a really important thing that the Navy seem to be looking at in this current stage. But then, yeah, absolutely moving into the future with these kind of podularization that the Navy have called it in some speeches. Not my favourite new buzzword, and I'll try and avoid using it ever again. But these pods,
next time you say it, you'll be fined.
Yeah,
we'll fine you the next time.
I'll try and keep it out of my mouth from now on. But these pods essentially are going to be ISO-sized contained mission modules. Essentially, it could be a strike package, it could be some kind of comms, could be all the equipment needed for a Royal Marines or any kind of commando landing group. So an ability to remotely get containers full of stuff around without having to use a helicopter is a long-term ambition, and this has been kind of illustrated by the Navy in graphics. But I think we are probably quite a long way off seeing some kind of drone that's capable of lifting these big heavy ISO containers full of kit and dropping them off on a ship. But the ambition is there.
Okay, we may be old and grey before we see it happen, but still, the intention is noble enough. I'd just like to ask you one other question, Harry, about the littoral domain and littoral strike. Obviously, this heavy lift capability framework has a big connection with that, as you said. But there's also Project Malloy as well, which involves a lot of analysis of unmanned naval requirements.
Yeah, so the Navy have been testing the Malloy made UAS for quite a while now. They've tested them out in Cyprus and on a few different exercises. I think that BAE have got a partnership with Malloy to some extent, and they've been just seen a few different capabilities. They've seen a torpedo kind of attached to the bottom of it, which adds an interesting launch mechanism for a ship to launch a torpedo. But as you say, in littoral operations and kind of supporting commando forces from the sea, the ability to use a small UAS that can carry like a 50 kilogram sack full of gear and drop it off is probably going to be more effective than having to launch a Wildcat or a Merlin helicopter, which puts pilots and an expensive airframe in harm's way. So there's lots of experimentation going on in that regard, and we've got a few articles on it on the website in the past where we've looked at some of that testing that's taken place as part of the littoral response group experimentation.
But I suppose, just being devil's advocate, it's all very well conducting experiments and coming out with plans and strategic concepts that involve maritime UAVs. But there's a there is a major practical dimension to using UAVs for carrier operations, for instance, and other operations from other kinds of vessels, isn't there? I mean, what kind of practical implications on ship design do we see from the more routine use of UAVs at sea?
It's interesting, yeah, because it obviously it depends on the design of the aircraft. If it's something that's a rotary wing UAS, like the Navy's looking at through Proteus, which is another story that Tim's written on and as I'm sure can discuss in much more depth than I could. But that obviously can just take off and land vertically, and so doesn't really need much modification to a ship design. But when you start getting into fixed-wing aircraft, you start to look into the fact that maybe you're going to need some kind of catapult and arrestor system, which the UK's aircraft carriers don't have. But then also that even has its own nuances in that if it's a short takeoff landing system, it might be able to just about do it on the existing decks of a carrier.
And there was some news from Farnborough, was there not, about... well, not a concrete move, but the idea of using Heron routinely for flights from a Queen Elizabeth class Royal Navy carrier. That certainly caught the eye, didn't it?
Yeah, so at Farnborough, as you say, IAI sat down with us for a conversation, and one of the things they said they were interested in the UK was adapting the Heron and the Heron Tactical platform to be a carrier-capable aircraft. So they said that they're planning on doing some trials in the UK to demonstrate the short takeoff landing capability. They didn't say when or if they'd actually be taking off from a carrier. I mean, you'd have to imagine that you'd have to prove it on land first before you'd get permission to do it on a £3.2 billion ship. But, you know, eventually it seems like that's kind of the route they're going down. And there's other options as well. There's versions of the... I think it's the General Atomics have come out with this maritime version of their Protector platform, I believe, which is designed for short takeoff landing. So there's a few different options out there, but yeah, the idea of Heron operating from the carrier was certainly an interesting one and not something we'd heard about before until Farnborough. Yes,
and as Harry mentioned, Tim, Proteus emerged as a story post Farnborough. I think it was announced fairly late in the day during that show, but has there been any further news since a few weeks back on that particular announcement?
No, I don't think anything majorly significant other than the contract being given to Leonardo, so it's like £60 million then, and this is for a 2 to 3 ton demonstrator for ISR and logistics mainly, to fly in 2025. So you know it's interesting because this is phase 3 of. Let me see if I can just get the acronym right. Rotary Wing Uncrewed Air System Capability Concept Demonstration.
Trips off the tongue, doesn't it?
Yeah, exactly. Phase 3. So, Leonardo have obviously previously done a lot of work with the Royal Navy on this prior to being given the new contract. But it is quite interesting in that. In terms of the money being given, £60 million is quite a bit when you can compare that in terms of similar in terms of prototype and Project Mosquito, and I know that's obviously RAF business, but that was given £30 million, and that's in effect a kind of loyal wingman type aircraft. Obviously cancelled, but we're talking double the money here, double the spend, and it'll just be interesting to see where Leonardo takes this, and as I say, then potentially worth also mentioning is that it could also be a successor system potentially to Crow's Nest, because that's going to leave service by 2029. So just in terms of early warning and things like that, really interesting to see if that's how Proteus progresses, because there is some suggestion that the RAF are heading in that direction. So it would be then beyond what is being suggested for testing initially on ISR and logistics and so forth. Really worth keeping an eye on if that's the direction of travel, long term.
Yes, it's certainly going to be interesting to stay informed on that, and I'm sure you'll be keeping a very close eye on it, Tim. While we've got you, let's just sort of turn to you for a transatlantic perspective, because so far we've only been talking about the UK. Obviously, the US Navy is very much at the cutting edge of new developments when it comes to applying unmanned and uncrewed technology to naval vessels. So do you notice any broad similarities between the US approach and what the UK is trying to do, or are there fundamental differences?
Yeah, I think there is some fundamental differences. I mean, you look at something like the MQ-25, an uncrewed refueler. The UK aren't moving in that direction in particular, but we're talking about production aircraft being manufactured next year from Boeing, and that'll extend the range of things like the US Navy's FA-18s, F-35Cs as well, and in terms of kind of almost looking at kind of historical achievements, that's how Boeing, when they had the first test flight and so forth, that's how they were pitching it, that this was kind of unheard of and untried territory, so it's to be fair, not that unmanned maritime vehicles are in any way new, but certainly the concept of an uncrewed refueler and being able to develop it, test it, and get it into production is absolutely new. So I think those types of things are slightly different to the Royal Navy's approach, and just obviously the funding aspects of it as well. There's no one really that can compete with the US DoD when it comes to funding and then arguably then ambition as well, perhaps. So yeah, and then there's other things that are kind of being talked about as next generation. So a family of systems under the Future Vertical Lift Maritime Strike to replace Fire Scout, and also then to replace the MH60 as well. So interesting, because that's going through an analysis of alternatives at the moment. So I think that's a 9-month program, the analysis of alternatives for FAL Maritime Strike. So we're looking at kind of Q4 then for next steps and so forth. But yeah, that's obviously huge, and it also kind of aligns then with the US Navy's Future Vision 2030 to 2035, and so that's we'll see where that one heads to as well.
It's a bit of a funny one, isn't it? FEL Maritime Strike, because hasn't only one potential manufacturer kind of broken cover and announced that they're definitely going to be offering a proposal for it?
Yeah, well, so I guess in the early stages, so going back 18 months or so, and I suppose beyond that, Bell have always said that they would look to the V280 or a maritime version of the V280 to meet requirements. But since then, there is definitely kind of firm interest from Northrop. Now they haven't identified a solution quite yet, but they have talked about potentially partnering with Leonardo, and that would be, you would have to think that would be a fairly potent partnership, given you could have Leonardo potentially doing the aircraft design or the the EW and electronics and so forth, and Northrop potentially offering weapons. Again, with the Fire Scout experience, then perhaps you reverse that, and it's Northrop who would do the aircraft design, and Leonardo would do subsystems and so forth. But yeah, that certainly has potential. I would have thought.
And Norbert, I mean, Tim mentioned the MQ-25, the Stingray, being used as a kind of an uncrewed platform for air-to-air refueling by the US Navy. It occurs to me that this is quite a fundamental change, isn't it? So is there not a specific training burden that has to be borne into consideration here?
No, that absolutely is, and as Tim mentioned, the MQ-25 Stingray is set to enter service in 2024 if things go according to plans, and it's going to be a first of its kind, right? So there are definitely novel challenges that will come with this UAV, and so I mean the U.S. Navy has actually conducted the first refueling operation last summer, if I'm not mistaken, with an FA-18. But this summer they've already they also done a sort of simulation, and it was the first lab integration to demonstrate how the Stingray ground control station will actually command the UAS in the carrier environment, and the U.S. Navy was working with the industry, with Lockheed Martin and Boeing, to sort of come up with a new approach, and they created this hardware-in-the-loop air vehicle that they deployed the first time, and it used real hardware and software to actually provide realistic surrogate for the UAS, if you will. And they simulated a number of things. It was a 2-day exercise, and one of them was sort of how to pick up lost link to verify proper GPS display indicators, which is very critical to ensure network connectivity between development environments. And the US Navy said that they are planning to simulate complete flight using this HITL in the coming months.
Okay, well, thank you, Norbert. That just gives listeners an idea of the complexity surrounding training for using unmanned and uncrewed aircraft at sea. Just going back to you, Tim, talking about the US Navy programs, as you did a few moments ago, is it fair to say that the US Navy, and to an extent the US Marine Corps as well, they're becoming increasingly reliant on UAVs for specific types of mission, such as ISR missions?
Yeah, I think actually when you mentioned that, it's interesting that kind of the US Navy have admitted there is a bit of an ISR gap, and that's as well as the MQ-25 obviously mainly being tasked to do refueling. It will also serve as a dual purpose and fill in that capability gap for ISR. So yeah, I think there is certainly a recognition that the reality of things is that there is a need to modernise on that front, and to get uncrewed systems to do a job in that area.
And is there a risk of becoming over-reliant? In other words, what are the pitfalls of the kind of strategy that the Navy and Marine Corps appears to be following?
No, I think not just the Navy, but others are kind of other MODs and certainly other navies are forced to look really hard at the balance between crewed and uncrewed aircraft in terms of future threats, and carrying out wargaming exercises and so forth. And even when you look at things like swarming, kind of conversations I've had of the really futuristic utility of maritime UAVs and swarming drones in particular. Some analysts have even talked about if you can get 50 to 60 uncrewed systems on a carrier, and you're, kind of end of day stuff with China, and you have them all integrated with fantastic AI capabilities, then potentially you could have 50 to 60 of these aircraft hunting down through AI, obviously, Chinese naval high valued assets, because they would have them basically registered in through software. The AI would automatically recognize them. So you would have, and again, this is as I mentioned, kind of very futuristic, but potentially 60 uncrewed systems or whatever, pick any number you want there, all rapidly identifying these high valued assets, whether they're aircraft carriers, surface vessels or whatever, and in terms of that target recognition and ability to send that back to chains of command and so forth, that is seen as a real game changer, let's say. So I know that kind of sounds fantastical, certainly, but I think when you hear it from analysts, and they're saying actually this is based on wargaming scenarios, the future fight will be ultimately dependent on how many sensors you can get into battle, and if you can get tens or hundreds more than your adversary, then that's obviously going to have a huge edge tactically.
Well, when you put it like that, it doesn't sound quite so far-fetched. Thank you very much, Tim. So just going back to you, Norbert, to talk a little bit more about the issues at play in terms of training for maritime UAS operators. You've already given a little bit of input on the MQ-25, but of course that's only one platform among many. So what are the big issues at play as far as you're concerned, looking at it from training?
I don't certainly know what the issues are, but we can kind of sense what the challenges are. As I suppose training UAS operators or UAV pilots in the maritime environment doesn't differ too much from UAS in other environments or in other domains. But the sensors, then the number of sensors that Tim just mentioned is probably something to pick on, definitely, because when I was talking to UAS or UAV instructors in the past, they had said that probably the biggest challenge in just training operators is how you can replicate the sensors, sensor views and the threats that operators may face while operating the aircraft, and potentially also being able to accurately model the maritime environment is going to be a big part of it also. And I suppose if we talk about the virtual training or virtual environment, which large majority of the US training usually takes place in that fashion, then recreating those complicated sensors and EW capabilities that we just talked about is going to be slightly different from overland or in the little area. So I think those are the ones.
Yes, so everything has to be seen through the context that you've just mentioned. In terms of actual programs at the moment, uncrewed aircraft could even be used for training purposes. Some navies are thinking. Is that fair to say?
Yes, I'm sure that the U.S. Navy has a few in the back too, but I think a significant one is the U.K. The Royal Navy's Project Vampire. They launched the program in early 2022, and it sort of seeks to, rectify the capability problem that the Royal Navy has recognized, which is the lack of low-cost fixed-wing UAS for ISR and electromagnetic and theater simulation tasks. And again, what Tim mentioned is the cost of using actually relatively cheap solutions to not just to actually defeat the adversary, but also, as you say, train our forces. And a few months after the invitation to tender was released by the MOD, they actually awarded a near 7 million contract to Kinetic under Project Vampire. And it's essentially, going to get target drones for the Royal Navy. And target drones are, interesting because they are generally remotely controlled and are used to train anti-aircraft crews for the development and testing of various systems, training crews on threat identification and also defending against fast jets and missiles too. And so under this contract, the Royal Navy will get, I think, ultimately 16 Banshee Jet 80 target drones with deliveries starting in 2023. And, if contracts are being extended beyond 25, then the numbers will go up to 2016. And, again, these are relatively cheap platforms, but they can be very valuable. And this new version of the Banshee is a dual engine one, which is a new version of the one that Kinetic released in 2010, and it has an endurance of 45 minutes, and it's fitted with a so-called hot nose system, which would allow the Banshee to provide a forward and also side-looking infrared sources, with the jet engine also providing a realistic reward-looking IR signature. And again, we just talked about it, the sensors and the signatures that these platforms give off and also read is going to be very important in a maritime environment, especially when you try to train your sailors as realistically as you can.
And also in terms of training involving drones, there's got to be a kind of training program, has there not, for manned-unmanned teaming operations, which by their very nature sound incredibly complex and incredibly difficult to train for. What kind of progress are navies making in this particular field?
Yeah, as you say, it's probably one of the biggest challenges. Or one of the most complicated training programs or training sort of solutions that forces are trying to come up with. And as opposed to just regular UAS or UAV training, you can't do it only in the simulation, right? Because you have to actually team up an aircraft, a crewed aircraft with an uncrewed one. And just going back to the other side of the Atlantic in the US. The U.S. Navy have completed a series of manned-unmanned teaming flight tests this summer during a two-week period, and they used FA-18 Super Hornets, and they actually successfully demonstrated C2 of the aircraft and 3 UAVs. But we know about it. We don't know what kind of UAVs they used for the test, but we know that the US Navy chose the F-18 because it has the largest digital touch screen in any fighter cockpit. So that was very important because during the test, the F-18 pilots entered commands into a tablet, which were processed and then transmitted through the Hornet's hardware. And then the UAVs executed all commands given by those pilots. So, again, it sounds very complicated, and it cannot be only done on the simulations.
Yes, it needs definite live tests. Thank you, Norbert. I'd just like to wrap everything up by asking the panel just one final question about swarming UAVs. Does the concept still hold water for navies to adopt, if you pardon the pun? And if navies are still looking at using swarming UAVs, how are they adapting their concept of operation? I'll just turn to you, Harry, first to answer.
Yeah, it's certainly a big question with, I suppose, probably a few different answers, and there's two parts to it. Is how do you employ them offensively, and how do you defend yourself against them? If you're there, like Tim said, I mean, if you send out 60 aircraft that are just scanning the horizon for threats, and they find one, they've got automatic target recognition, and they just require a green light from an operator to then go and strike it, the air defense threat becomes even harder for a defending ship or task group to counteract that, especially if there's such a huge volume of threats. So on the defensive side, you're going to have to see navies probably with longer range sensors that are able to detect increasingly smaller threats at larger distances, and just detecting them is only one half of the problem there. You've got to then have the software and the processing capability to classify, prioritize, and respond to those threats. So that will, again, you're going to have AI in the swarm. I hate to use AI as like this thing that's kind of sprinkled on everything as a little bit of magic that makes it better at fighting. But you're going to need to have AI, whether that's some kind of machine learning algorithm or far more complex computing than I understand, to pick which threat to respond to first, what weapon you use to respond to. And then it also adds to the challenges of navies there, is if you're in an air defense destroyer and you've got 60 swarming UAVs coming at you, and you've only got 48 missiles on board, you're either going to use up those missiles very quickly trying to defend yourself, or you're going to have to look at things like airburst ammunition in your main gun, kind of what we all know in World War II as flat guns, to try and defend against those threats, or whether you're going to need to have more things like small rolling airframe missiles to defend yourself, or then you stray into the territory as well with the directed energy weapons that aren't limited by magazine depth. So the swarming challenge is a huge one, and you definitely see navies looking to increase the missile arsenals of their ships, looking at ways they can use different types of ammunition from their guns, and investing in directed energy as means of defending themselves. And like I said, that's just one half of the problem. The other half is then developing and figuring out how you effectively actually deploy these swarms in the first place. How do you launch them? Where do you store them on a ship? There's limited space on a typical grey hull. How do you command and control them from a ship when you might be in a degraded environment with limited bandwidth? Lots of challenges, and two parts of the problem would be my, I suppose, non-answer to your question.
No. It's very interesting, and it has actually raised a series of other questions that unfortunately we don't have time to go into in even more depth, but it still raises a very important issue. I mean, from your perspective, Tim, do you have anything to add?
I have to say, I think Harry's summary there was fantastic. I don't have anything other than to suggest that I think the tipping point will be if we do get wind of it being used in anything other than trials and demonstrations, then the proof of swarming drones as a kind of operational concept and so forth, then that it is not just feasible as we kind of continue to hear, but actually that it's being used effectively, and not only to strike representative threats or used being trials, but it's on the front line and being used to good effect. I think that will be the really significant thing to see. I mean, you go back to the likes of the US Army using uncrewed teaming for, with rotary wing and Grey Eagle and so forth. That was the early days, and that was kind of it seemed to be that's going to open the way forward and the gates to everything being or all sorts of teaming and so forth. But the floodgates haven't really opened operationally on that front. So, and you'd have to ask, well, why not? So I think maybe something similar here would be fairly obvious, that type of comparison anyway.
Thanks, Tim. And Norbert, I mean, how advanced is training against swarming UAVs, given, as Harry and Tim have said, that we haven't really seen any real-world examples in the naval domain of swarming UAV attacks, thankfully?
No, that's right. Not personally, I haven't seen anything either that, the navies would start taking it, seriously enough to actually start training against them. And since the capability actually doesn't exist yet to train, to deploy them, we couldn't see that either. But I would just, also I would echo what Tim and Harry said and just add that, all those sort of challenges and aspects to consider with swarm UAVs, I think it's important to mention that not every navy will have the actual economic capability to even consider those, right? So that large navies or large, defense, organizations like the US DoD or perhaps the UK MOD, China will certainly have money for that. But if you're a smaller navy, although yes, these UAS and swarm UAS will be relatively cheap to implement all those sort of technicalities that Harry outlined before, is just going to be something that not everybody will be able to do, right? Because of the restraints they have on their defense budgets, and we can see some defense spending uplifts. We could see in the past 6-7 months, but when inflation reaches almost 10% across the globe, then the question is that how much of a difference to 0.5% extra or 1% extra on your defense budget will make in real terms? Probably not much, I think. And again, same point. All these things all these challenges to be overcome, you need to invest in R&D, and once inflation starts sort of biting into your R&D projects as well, which is usually the first area that suffers, then again it's a bit questionable how smaller navies will be able to consider swarming UAVs.
Thank you very much, Norbert, and thank you also to Tim and Harry. So that's it for the latest episode of the Shephard Defence podcast. But if you're listening to us, perhaps for the first time, and would like to sign up for a 14-day trial to our news and analysis, go to businessinfo.shephardmedia.com/news. The Shephard Defence podcast was brought to you by Shephard Studio, featuring myself, Ben Vogel, Harry Lye, Norbert Neumann and Tim Martin. Stay tuned for our next episode in September, but that's all from us for now. Goodbye.